All right, hey everyone. I'm Nils. I've worked on Composer for a bit over 6 years now. I had its 6th anniversary in April this year. And it's been kind of a great honor to work with tons and tons of people on this project. Much like what Rasmus was saying about PHP earlier, Composer at this point has had so many contributors. It's been exciting to see it grow and actually get mentioned in, I think, pretty much every session so far that we've seen today. And as part of making this open source project more sustainable for the future, so that we will be able to continue to work on this project with as many resources as we've been using, that so much of the PHP world, so many businesses using PHP now depend on, we started a new business called Private Packages that I've mentioned on here. That was mentioned, I think, even in a previous talk, where the idea is to provide additional tools around Composer that are useful to businesses, to use the financial resources we get out of that to support our open source development efforts. So do take a look at this after the talk. Come talk to me about it afterwards. I'm here for the rest of the conference if you're interested. But today, I want to talk to you about managing dependencies in general. The title is Managing Dependencies is More Than Composer Update, and so I want to kind of start by taking a step back and looking at, what do I even mean by dependencies? Because there's a lot more dependencies to software projects than the libraries that you can manage with Composer. So I think overall we can split this into kind of two main categories. The first one is services. These are external APIs that you're making use of, some kind of third-party service that you're integrating with. This might be some kind of client-side integration if you're working on the web. Let's say some kind of OAuth login, which is again like some external service that your software depends on for at least some of its functionality. And the second part is what I'll just group in under software, which are really these pieces of software that you can install. So part of that are the libraries, but part of that are also tools, like Composer itself really is a dependency of whichever project you're working on. The operating system you're running on, all the different kind of libraries, all the different tools that you're working with. PHP itself is a dependency of your project. Right, so there's like different aspects that you have to consider. And I mean, obviously your project's going to have a lot more dependencies, but I'm not here to give you some kind of HR talk, because obviously you have dependencies on whoever's working on your project. You have lots of other things, but we'll try and focus on kind of these things that are related to software. And you can definitely include something like external assets in there, which I'm not really going to talk about the rest of the conversation for the talk here today, which are things like images from external sources, some kind of documents, etc. So that is what dependencies are. Then what is dependency management as a whole? And I think you can group this into 3 steps of a process. The first one I will call assembly, which is really the idea that you put together all these different things that you need to build a whole, which is your application. So once you've done that, the dependency change management is everything related to modifying this kind of application as a whole. So we'll talk in detail about what exactly that is, but modifying what gets assembled, in a sense, is changing this. And most importantly, and what we'll talk about for most of the talk, is how do you analyze what risks exist while you're doing this, and how do you minimize or reduce these risks? And this may exist both at build time. So Composer itself, for example, I said is a dependency, which you don't use like while your site is running, but during build time. And this may happen at runtime. So let's say your dependency on this OAuth login mechanism is something that happens while the application is running. So let's start with dependency assembly, which I think is the easiest to grasp out of these, which in the easiest form is really just running a composer install, for example, which will install a set of libraries. But it's also, say, an apt-get install of some library or some tool on your system. Right? So it's like putting together the entire environment that your application lives in. Part of that is the PHP libraries that you use, but part of it is the context and the environment that your application runs in. And hopefully you're using something like Puppet, Chef, Ansible, some kind of configuration management system to create the state that's reproducible that your application runs in. Assembly also means the configuration for connections to services. Right? So this is something like setting up the authentication credentials for an external API, writing some kind of glue code that gets assembled together with the API to make it accessible in your programming language. And at runtime, it's the actual connection that's being established to the external service, right? If you have a runtime dependency on some external service, where a particular site will only load if it gets something from the API to display to the user, then you have this dependency at runtime and connecting, like that's the actual assembly part. One key change that you can see in this process of assembly over the last years, that Composer is one tiny part of really, is that we've gone away from these step-by-step installation instructions. You know, if you go back 10 or even 20 years, usually if you get a piece of software, you get a set of installation instructions with it. Like first you have to install the following tools to be able to run this. You have to make sure that you have the following runtime environment. Your system needs to support this and that. And you kind of go through these step by step by step, and then there's like a lot of unnecessary instructions, and sometimes somebody forgot to add one because they thought this was always the case. And then you end up with errors where you can't quite figure out why isn't this running. You know, so we have like these long readmes of, oh, you have to delete this one library over here because it'll conflict with what you're doing. So today, instead, we describe the system as a whole as we would like to run our application. So we've come to a point where we, rather than give somebody a set of instructions that they have to manually go through, we try and give it overall precise specification of what the state of the application needs to be for it to run. So tools like Composer, like Salt, enable you to go from whatever state your system currently is in to the state it needs to be in to run the application. Right, so the idea behind Composer is not that you tell it to install one library, but the idea is that you tell Composer what is the state of my application that is required for the application to have met all its dependencies so it can run and execute successfully. Okay, so that's how we assemble things. The next step that I said was dependency change management. And I don't mean change management in the sense that if you look it up on Wikipedia, it's like this very formal process for managing change. It's more like a colloquial term I kind of made up for this. And what I mean by dependency change here is quite simply adding a dependency, removing a dependency, updating some library you're using, replacing some API you're using, that kind of thing. And usually you do this in the PHP context by running something like composer update. But obviously, like I said, there's different aspects of where you have dependencies, so there's different tools for the different areas that you're using this in. And then dependency change management is all about figuring out what are the risks involved in adding a particular dependency, removing a dependency, updating a dependency. What are the consequences from doing that for my application as a whole, for my engineers, what do they have to work on? What are the costs involved in adding or removing this dependency? What are advantages I get out of it? And it also means architectural decisions that enable future change. So an example that I have on here is you can always create some kind of abstraction for a concrete service that makes it easier to later replace it. So managing the change of your dependencies, in some sense, also means predicting what may change and finding suitable ways to prepare yourself for that. So now that we have this thing covered, what does this all mean? What I want to do with you is kind of go through different types of risks, look at how do we even identify these, and then what are good approaches to working on that. How do we improve these processes? How do we actually avoid all the problems with them? So the first one I want to look at is availability. It's a type of risk that you have, and it mostly affects the assembly part of managing dependencies, right? So for example, there's a very popular or rather very well-publicized case in the JavaScript world of an open source library that the author deleted. I would say kind of out of spite over some other issue that was sort of unrelated to this particular library. And because nobody really thought about the risk of availability of these open source dependencies, it resulted in a majority of JavaScript builds in the world failing because this small tiny library was the dependency of some tools that a lot of people were using. And the same, to a degree, can and cannot happen with Composer and Packagist. We have a couple of safeguards that don't make this quite as easy, which do exist in the JavaScript world nowadays as well, so you can't just easily delete something off of Packagist. But it's important to keep in mind that on packages.org, all we do is host the metadata for packages and versions. So when you run a Composer install, it'll go to wherever the author of the open source library specified. So if the author is hosting this on GitHub, your Composer install relies on GitHub being available in order to install this library. And the open source author and packages can submit anything, so it could be their self-hosted Subversion server somewhere. Right? So it's kind of important for you to analyze this type of risk, see what availability do we actually depend on for our processes to work. But stepping away from Composer for a second, there's other kinds of things that may become unavailable that are dependencies of your software. So let's say a payment service that no longer reacts. That's always like a big problem if you're trying to sell people something, your payment service doesn't work anymore. That's something you've got to figure out mechanisms to deal with. We'll get to how we kind of approach all of these in a minute, but I just want to make you aware first, like, where are these types of risks? A favorite of mine is this European VAT ID service. I don't know if any of you have ever had to deal with this. It's this little service that the EU provides to validate VAT IDs of companies that you require to invoice them correctly. And I feel like it's down probably, I don't know, at least a day out of the week. So it's it's a little difficult to work with if you're trying to use this as part of your payment system for customers, and then they always run into these issues over the VAT could not currently be validated. So it's also something you need to look at. What am I doing in that case? Or going back another step, like I said, these are things this can happen at build time even for a service, right? So if you're relying on some Jenkins system that's building your services in order to deploy, even that may be down at some point. Even if it's run by yourself, there may be some maintenance going on. That too is some kind of availability that's part of your dependencies that's a risk to your project. So let's look at how can we reduce this type of risk? How can we minimize this? So for software, this is relatively straightforward. Sorry, I think there we go. The slides were there while I was talking earlier, though, right? Okay, good. So making sure, because I'm not looking there all the time. All right, so for software, this is really straightforward. If you have a copy of the software, you have it's available to you. Like, that's really not really much to think about. But the question is, where do you have a copy? So there, for example, Composer has a cache directory that it keeps copies of the software you've currently installed. So let's say some external source is no longer reachable, you can't get this thing anymore. That's a way to maybe kind of recover. As you see, maybe one of the developers still has a copy of the software and you can move it somewhere else, but that's definitely not very reliable. So I've seen some businesses actually fork every single open source dependencies that they have in order to keep a copy of this so that they're certain that they can't lose this dependency. That too becomes kind of a maintenance burden because you have to keep updating those. It's like a lot more work once you have a fork of each of them. It's definitely workable, but depends on the amount of effort you want to put into this. And the alternative is to set up something like private packages that I mentioned earlier, or Satis, where you run your own Composer repository that keeps a copy of all of these open source dependencies, so that if any of them are unavailable, you still have your local copy that you can work with. For services, this is obviously a little more difficult because usually they're run by third parties. So you can't, a service you can't keep a copy of and then it works. But there's approaches you can take architecturally that will avoid these issues or at least make them more manageable. So let's say, for example, calling a service asynchronously will always make it easier for the user to understand what's going on. So making that payment go through and then later asynchronously in some background process checking the EU VAT ID and then notifying the user to please correct it if it's wrong is probably a lot more usable than the payment failing immediately just because we couldn't reach this external service. So if in any way possible, try and move these runtime dependencies to as isolated a location as possible and try and have them not interact with users as much. So like another example, when we were building private packages, for example, we don't want to rely on GitHub being available. So while we have this GitHub integration, and if you log in, it like loads something from the API, we don't want this to happen inside the web request, because then as soon as GitHub is unavailable, our site doesn't load anymore. So instead, we have this happen asynchronously in some background process, and then our front end simply communicates with our internal cached store of this GitHub data, so that if GitHub isn't available, simply not like say like, hey, we couldn't load this at the moment, the rest of the site works fine. And so an important thing there are low timeouts. It always amazes me how many API client libraries either have unconfigurable timeouts or have really high default timeouts. If I'm connecting, like if I'm in a web process and I want to connect to some API, get a response, and then show this to a user, a 10-second timeout is not acceptable, because if it actually takes 10 seconds, the user will have canceled loading that page and left in the meantime. So if you're talking to external services, use low timeouts. Worst case, tell the user, hey, we couldn't connect to their external service, explain to them what they can do. Don't just wait forever, because that will not work. All right, another type of risk is compatibility. Something I'm sure we've all run into at one point or other. And this is really something that affects change management rather than assembly itself. Right? So if we update some dependencies, we may run into backward compatibility breaks where suddenly some of our code runs into fatal errors, build doesn't work anymore. But even on an API side, this can happen where the semantics of some API change. Like something I've seen before is where a payment API no longer supports credit card tokens, but only these payment tokens that are more generic in order to support new payment methods like Apple Pay. And this isn't immediately transparent while updating because they kind of just replace this one token with the other. So it looks like your code is still working, but then when you actually try to make a payment, it fails. Right? Because the semantics change rather than the syntax. But yeah, I imagine you can all think of various things that can go wrong when updating something, as I'm sure you've all run into lots of these. So let's rather take a look at what can we do about that. And I think the most first step here is really thinking about how do I even pick a dependency, right? Change management isn't just updating, but it's also adding or removing dependencies. So especially for a new dependency that you're adding, but even if you already have it, this is worth looking at. So the list of criteria I have here that I think makes sense to look at when you pick a new dependency, or if you have an existing project that you should be evaluating each of your dependencies with, is something like the number of maintainers, developers of this library. Is this like a single person who's doing this in their free time, or is there like a large distributed group of people in different companies that have an interest in this that are maintaining this? Is it actively being developed? Like each one of these isn't necessarily a good or bad indicator, because there's great libraries that are developed by a single person that have very little activity because they're just very stable, they're very small, it's just something that everybody uses. So it depends a bit, right? You have to look at the particular cases. So if you're trying to identify how many people actually use something, packages actually lists the number of the installation count, which can be helpful in that. Don't trust the absolute numbers too much, because this largely depends on who has how many CI systems that are installing something, and that's not a good indicator, but it's great to compare. If you see that something is at 0, it's probably not being used much. So don't read too much into the actual number, but it's a good indicator to see whether something is being used or not. Then, to avoid this availability issue, take a look at where is it actually being installed from, right? Is it coming from something like GitHub, where I have relatively high security of it actually being available? Or is this some custom self-hosted, I don't know, Mercurial server somewhere? Do I want to really rely on that? And what are the alternatives? Like, if this no longer gets maintained, how easy would it be to replace this with something else? How complex is it? Could I build something like this myself if it was no longer maintained? Or how complex is it in the sense of, do I understand it enough that I could take over the maintenance of this project if it doesn't get maintained anymore? Is this something that I could potentially work on if nobody else does anymore? So I'm a little curious, who of you actually consciously thinks about this when they pick a new dependency? It's like a couple, it's nice, more of you should be doing this. Right, so that's how we pick or decide what dependency we want to have. But then when it comes to actually updating them, one thing that promises compatibility that has been adopted through our composer quite a bit is semantic versioning. And the whole idea behind semantic versioning is that you have these version numbers, pretty much like we're familiar with, but everything is backward compatible unless the X gets incremented. So as soon as there's any backward compatible break, the X in the beginning gets incremented. Now the problem with this is it must actually be used consistently. And I've seen so many people working on libraries that go, but it's just a small break in this one particular case. I'm sure we don't have to increment the big number for that, right? And the problem, if you do that, is that users of the library cannot depend on this promise, right? As soon as you even once decide that you can make a BC break and not increment X, the entire promise is worthless. Because your users will upgrade and they will get errors, even though they expected to be able to upgrade. So basically, if you're working on any of these libraries, you make any versioning decisions and you want to use semantic versioning, don't be afraid to increment X. It's really important that you do that so that your users get a clear message about what's compatible and what isn't. Now, the other thing with that is, what does backward compatibility break even mean? Right? If that's just a feeling about, this is probably something somebody uses, and it might not work afterwards anymore, then it's also not very useful, because that may or may not be true. Like, it's not a useful promise to users of a library. So it's very important that what exactly BC means be formalized. And a great example of this is the Symfony framework's documentation of BC at this link here. It's pretty easy to find if you just Google for Symfony and BC, where they formalize exactly what type of promises they make about whether they will be adding arguments to API calls, if they will be changing function names or not. And it just makes it very explicit and clear what will and will not change in a minor release. And only once you've done that is semantic versioning actually a useful tool to automatically manage dependencies. Now, on the other hand, as a user of a library where you see that they're not following this, where they're not formalizing this, so you're not sure if they will or will not break compatibility, they might not increment the X because they want to have a nice version number, which is not useful to anyone, but it looks nice, then maybe pick more strict version constraints in Composer, for example. So, use something like the tilde operator that upgrades from 1.2.3, like only the last digit, so it would not upgrade to 1.3, to make sure that you manually do these updates and review what has changed. And that's something you can kind of do based on experience. There's lots of ways to work with compatibility. I kind of wanted to highlight these two. There's, obviously all your tests help you figure out problems. Once you've updated, if you do static analysis, Rasmus was showing this little tool he built in the first talk this morning that can help you find these types of incompatibilities once you've upgraded a library. There's manual things, like you should be reading changelogs of libraries that you update. And if you work on a library, actually write them. I'm curious, who actually reads the changelogs of every dependency of the project when I run a Composer update? It's like a very, very few hands.
Question.
Yeah, sure.
Why don't you include it when we run a Composer update?
The issue with that is a bit that it's not currently standardized in any way, so it's kind of like a big mix, but I would like to actually do that. I think we may at some point offer something in that direction. Just to repeat the question, because not everybody heard, he was asking why this isn't included if you run a composer update. And it's really mostly because there isn't currently a standard for how these changelogs are presented, but I think that that may be changing in the future, and that there's more emphasis put on this. But regardless, I think Composer makes it really easy to discover them because it does give you the links to every individual dependency, and it's easy to kind of see it on there if they have it. Yeah, last one I think I kind of mentioned was just based on your experience with which libraries break BC frequently, you can kind of pick the right versioning constraints. So, talking a bit more specifically about Composer, since we're at the PHP conference here and I work on Composer, some specific things you can do when updating dependencies with Composer. If you just run Composer update without any arguments, you end up updating everything at once, which means you have no isolation of individual problems during the upgrade. It's very much like running a unit test for your entire application as a single test. Right? The idea behind isolating tests, for example, is that if one little part fails, you know where the issue is. And in a very similar way, if you run a Composer update of everything at once, and you only do this, let's say, once every couple of months, you will get a huge amount of updates, and if something breaks, you have no idea why. So one solution to that is to actually run this update on a very, very frequent basis, like on a daily basis, make sure that everything is up to date all the time. Because then, obviously, the amount of changes this introduces is going to get lower, so you don't have as much of an issue with this. But I'd say in reality, we do end up working on projects, we get onto a new project that hasn't been updated in a long time, or, I don't know, like people are on vacation, nobody's been, doing dependency updates for a while, like this happens. So a much more safe way to approach this is to run Composer update with individual packages as an argument, which will only update those packages at a time, and to just do this for each of your dependencies one at a time, so that when one of them results in test failures, you actually know why. If you do Composer update and some name of a package, I think it's not well understood how this actually works. So I have this really ridiculous made-up example here, where the package called zebra, a package called giraffe, and they depend on a horse and a duck. No worries, you don't really have to remember this. I'll have it as a graph in a second, and then the horse actually depends on the giraffe, and the duck doesn't have any dependencies. And then in my project, I'm using the zebra and a giraffe. So this is kind of what this looks like, right? I have my project, depends on the zebra, the giraffe, the horse depends on the giraffe depends on the duck. Now, each of these packages releases a version 1.1, and we want to do an update. Now, if I run Composer update of zebra only, it'll update exactly that one dependency. All right, that's kind of what we expect, I would say. I mean, we give this argument, that's exactly what it does. Now, usually, since in our Composer JSON of our project, we've only listed zebra and giraffe, horse and duck don't even come up in there. I don't really want to go through and have to list every dependency of every dependency in order to go through this process. So Composer update actually has a with dependencies option. With dependencies, we'll update zebra that's in your Composer JSON, and then look for all of its dependencies and update them too. So it'll go to a horse, and then it'll go to a giraffe. Right, stop. So it doesn't actually update giraffe. The reason for that is that giraffe is a main dependency of your project, so it doesn't touch that. So it'll update all those dependencies that you aren't managing yourself in your Composer JSON. So in this case, it'll update zebra and it'll update horse. So if we update zebra and giraffe, it'll update exactly zebra and giraffe. And then if we run this with dependencies, it'll actually update everything. So the key really is that this with dependencies doesn't touch anything that you manage yourself, because you're expected to manage whatever is in your root Composer JSON. This is why things like a version alias only applies in the root Composer JSON, why something like the minimum stability only applies in the root Composer JSON. That the set of dependencies you have in your Composer JSON, those are the ones that you know you need to manage. Okay, speaking of updates, next thing that you're confronted with is the lock file. Just to quickly go through, what is the purpose of the lock file? What does it contain to begin with? A list of all these dependencies. So in the previous example, all 4 of those, including transitive ones, right? So even the horse, which wasn't mentioned in my composer.json at all. And it contains an exact version number for each of them. So not a version constraint, but an exact number. And it contains the metadata for the respective package and version. So that's the URL where it's supposed to be downloaded, like the Git repository where it was originally from, the requirements it had at the time, hashes of files that are to be downloaded. And the purpose of the lock file is to make composer install reproducible. This means if you're working in a team, another teammate will get the exact same result. I wonder why this keeps happening. The same is true if you're building an application that you ship to users. Right, let's say something like what was he mentioning earlier, WordPress or PHP or something, where your users actually run the PHP program themselves. They too should be using the versions of the dependencies that you tested your application with. And it isolates the cause of bug reports. Right? So even in a library, this is useful because you know that if somebody is reporting a bug to you that they ran the tests you through, the bug is in the library and not in a dependency. The other advantage you get with what I was saying earlier is that the process of updating becomes more explicit. So because you have this log file and it's in your Git repository, it's very clear that somebody decided to upgrade a dependency of a dependency, that this is the point where this changed. Because otherwise, you have your development progress, like maybe you use some API or something, and your code changes, but nobody sees that that's because of a change in the dependency. Right? If you have a commit there that modifies the log file, then you know that the other change that came after that now uses the API in a different way was because of that change in the log file, the dependency update. So it makes the whole process a lot clearer to other people who are later reviewing your work. Which is why it's so important that you commit the log file into your version control system. If you don't do that, composer install without a log file is actually a composer update. It will actually display a little warning and continue to do an update, which means you will get any version installed that sort of matches your constraints, which may be a very different version. As we saw, people don't necessarily do semantic versioning correctly, so your application may actually break if you run a composer install without a log file. This affects assembly because conflicts that put the application together can now randomly occur while running a composer install. Yeah, so maybe these versions actually don't match up anymore if I do a composer update, and without a log file, I'm always doing an update. You may not get the same code, right? It may just decide to install a different version. So in reality, you're no longer managing this change. It's like the change just decides to manage you, right? It's just installing whatever it feels like doing. So the purpose of the log file is to be committed. Like that's what it exists for. Now, once you do that, what you'll eventually run into are merge conflicts in log files. Who's seen one of these before? All right, that's a lot more hands-on with previous questions. Now, that is actually intentional, and I'm going to try and explain to you why it's so important that anytime you change the log file, it conflicts. The main reason for this, I mean, you would assume that often enough, why can't it just merge those two, right? Like, I updated this dependency, my colleague updated this dependency, it should just be merging those. Like, why doesn't it do that? So the reason is that it contains a hash over the relevant values in the composer.json, so that anytime a composer.json gets modified, the hash gets modified. So this hash will always conflict. And the correct way to resolve this is to check out the log file of whichever base branch you have, so usually something like the master branch or whatever else you're working on, and to then run the composer update that you did again, right? So you have to repeat this composer update. In order to do that, you need to know, how did I run composer update before? And if I don't just run composer update without arguments, but usually use these arguments to do isolated updates, It's useful if I create a separate commit that only modifies the lock file where I document specifically what I updated, so that if I later run into this issue, I can go look in the message. It's like, this is the exact command I ran. I'll just rerun this. And then the log file gets regenerated based on my changes and the changes in the original branch, and I can commit it, and it's fine. Now, to explain to you why a merge is not safely possible and why it's a good thing that this hash will conflict, let's assume my example from before. I have two different branches going on here. One person is working on the left, one person is working on the right. Person on the left operates Zebra 1.1, which now has a dependency on Duck 1.0. A week later, oh, come on. Not on my side, all right. A week later, I on my branch upgrade Giraffe to version 1.2, which has a dependency on Duck 2.0. Right, this is like two things that happen at different times. They're just sitting there, those branches. Now, I'm trying to merge my thing back in here. What will happen if I actually do a merge? It's happening at the best times. All right, there we are. All right, what will happen if I actually try and do this merge? You know, if I did this on a text basis, where it's just, there's like this one piece of JSON and this other piece of JSON, and I just stick them in the same log file, it would actually have Duck 1.0 and Duck 2.0 both in the same log file, because they were independently added in different sections of the log file, and that would not work in PHP, because you would suddenly redefine the same class names in the same process, and it would break catastrophically. So instead, what you have to do is you have to take the bases with Duck 1.0, rerun the update, and you actually get to a state where Duck 2.0 now satisfies both of those dependencies. So it's very important that this conflict exists, because the composer update process is actually something that doesn't need to happen again. All right, let's put the whole updating aside, and let's take a look at another type of risk that I think most of us developers don't like to look at so much, because it's kind of like this annoying thing that also exists, which is any like compliance rules in your business, legal issues around dependencies. This too affects mostly change management. Examples are if you're shipping a proprietary product to customers and you contain some viral copyleft license like the GPL, you can't do that. It's incompatible. It's illegal to include that in your software. For services, I think that's like a more common thing that you have to deal with. There's usually terms of service, where the question is, am I even legally allowed to use the service? Has this been happening like this much the whole time? I'm really sorry about this. Am I even allowed to use this particular service for what I'm going to do with it? So an example that I think Jordi brought up with me in a recent conversation about packages.org, where the question was, just ignore this thing for now, I guess. I'll just talk without it. I hope this doesn't distract you too much. Why can't we use Cloudflare to distribute all these JSON files for Composer? There's like other technical reasons for that that have to do with the frequency at which it changes and a few other things. But one other thing is that the terms of service for Cloudflare actually specifically state that it's only to be used to be a CDN for HTML content. So we were to ship all our JSON through there, and any day they could just decide to shut the whole thing down, because this is what their terms of service say. And if you're adding an API as a dependency to your application, you should probably look into the actual terms of service and identify whether that is some kind of risk to what you're running there. Can they shut you down from one day to the other without notice? How much time do you have to actually move away from the service if they decide to terminate you? How would you approach that? If I have issues with it, do I actually have an SLA that provides me with sufficient support? And usually, the answer to these is, let's skip out to the minimization, to put resources into them. With software dependencies, it's really mostly about the licenses, so you can run Composer licenses, which is a command line, part of the command line that lists you all the licenses in your project, so you can go through and analyze which of those you are actually allowed to use. Private Packages has a tool that does this across the entire organization that you're using in there, called License Review. But for terms of services, SLA, and contracts, it's sure you can also use this as a criteria for selecting the service, but I think the key to take away there is that these things are usually negotiable. Get in touch with whoever's offering the API and see if they're not willing to maybe move over a bit on whatever terms they have. And a key takeaway there, I think, should be that if you have a strong dependency on some external service, some external library, that's probably where you want to invest some money, right? So if you have a really strong dependency on this one open source library that's maintained by some random person in their free time, it's probably worth putting some developer hours to help this person maintain the library. Maybe to do some kind of sponsorship thing. Or if it's a service that you're paying for, it's probably worth actually paying for that extra money for the SLA if your entire business depends on this existing. So do consciously make these decisions. But I think, don't go away from this scared that, everything is terrible, there's so many risks, and like, I have to build everything myself. That's the exact opposite of what you should be doing. You should be formulating a plan B, so that if any of these issues come up, you know what's a good measure against them. What can I do? It's like an easy workaround. Maybe I can set it up today. Maybe it's just knowing that there's this other API available that we can switch to within a month if we ever get terminated by the first one. Right? But at least have consciously thought about it at some point and identify for yourself what is the alternative, what are we going to do if that happens. And then identify which of these problems are actually likely to happen, which are very probable, and are their effects catastrophic for me as a business, or are they kind of like a little minor annoyance that I can deal with? Because dependencies overall are great. They will save you huge, huge, huge amounts of money if you don't develop everything yourself. They will do so by saving you that amount of time in developer time, and with services often they'll also save you money because it's just way more efficient to use a service than running and maintaining and operating the whole thing yourself. So do spend resources on these things, but spend the resources smartly on the types of issues that are actually likely to affect you. Yeah, so reduce the risk down to a level that's acceptable. The goal is not to remove it or eliminate it entirely. You will always have some of these risks. You will have dependencies. It's great, they will save you money, etc. So it's just important that you figure out which ones of these spots are the key areas I need to look at. So as a summary, from a technical perspective, use composer update with arguments, with a dry run to figure out how and when and what you're updating. Use git checkout branch -- composer.lock to get your lock file from another branch so that you can run the update again. Formalize PC promises for users of your libraries so that they can rely on semantic versioning. Don't be afraid to increment the major version. And when you make changes to dependencies, document them so that they become part of this whole process of managing dependencies that others can understand and that makes it clear what you're doing. And regarding the whole risk process, just make sure that you look at these different types of things that I pointed out, that you formulate a plan B, and even if that plan B is just, we can deal with it another day, that's perfectly acceptable, but just think about it at least once. I know there's always this great question of who here has ever migrated an application from MySQL to PostgreSQL? It's like 3-4 hands maybe. Were you able to do so by just changing config variables, or did you have to change some part of the application? Raise your hand if you were able to do just with the config. There's actually a person here. That's one of the first times I've seen that. So the reality of this is, if you're sure that maybe this will come up in some project, but it's probably not worth investing huge amounts of effort into potentially having to do that one day in the future. Focus on the things that are likely to actually happen, or that are very risky to your business. So, having a plan B for that payment provider that you really, rely on to even get any money, probably more important then can I switch to Postgres in 1 week or 1 month? Right? The latter is kind of not that big of a deal. So don't waste resources on potential problems that are unlikely to occur or have insignificant effects. But overall, dependencies are great. Their benefit is usually significantly greater than the cost that they have. And I think an important thing that developers should think about more is this business understanding of what dependencies are, right? Like, don't spend a huge amount of time on building this abstraction layer on top of some little library here because it's cooler and more correct that way if it doesn't provide any business value. If it's like a small little library that your business kind of needs for this one corner edge case for 3 users. Sure, maybe the code doesn't look that pretty, but from a business perspective, it's just not worth spending that much time on. And at the same time, maybe don't just add 200 new dependencies on different little things without mentioning this to anyone in your business. And then they're very surprised, someone who doesn't know the code, that their application doesn't work anymore because all of these maintainers kind of decided to move over to this new framework. It's an important thing for these two parts to share. So that too, management, like the business side, needs to take this seriously and communicate about this with developers because it has a very strong effect on the business as a whole if developers decide to add all these dependencies. And while that may give great benefits, it's important that the entire company understands what's going on and where the effects are and what are the plans so that you can deal with this. So with that, thank you very much. And I think we have some time for questions. You with the mics. Kind of hard here. Anybody? Feel free to ask anything about Composer or so too if you want to. Well, all right. Well,
It's okay.
There's one right down here.
Huh?
How do you feel about committing the lock file in a library versus committing it in a project that's consuming a bunch of libraries?
Right. So I think I briefly mentioned this, that there are advantages to committing it in a library too, which are that if you have other contributors come in, run the test suite, report a bug that they ran into with the test suite, you actually know that the bug is not with the modified dependency versus what you were testing with. Overall, it's not as important as with the project, obviously, because it's not important for the users of the library. It's only important for other developers. If you're working on a library, most likely you will want to do something like a composer update, and a composer update prefer lowest, etc., to get different version numbers in your continuous integration anyway. But it's still great to have the lock file in there so that the base set that you're working with, if you're working there locally, kind of matches what the others do. So there's some benefit you can still get out of it, but it's definitely not as big as for an application that you're working on.
Any other question?
One in the back over there. Actually.
Hi. One of the talks on Composer, they were sort of explicitly against doing things like Composer update, especially on your live environment.
Yeah.
Generally, they were saying that you should get to a stable version of where your application is, and then just do Composer install across everything, and then basically keep it at that stable version, and then only do upgrades when absolutely forced to do so. I mean, generally, your view seems to be the opposite, that you are constantly updating, constantly getting the latest versions and stuff.
Actually, I think I agree with that entirely. The point is you have a state of the application, you only run a Composer install, you run Composer update specifically when you want to update. Now, my position on this is that I do want to update on a regular basis, right? I don't want to run insecure software, I don't want to run outdated software, so I do the Composer update on a regular basis. But I do that as a developer consciously deciding, today I'm going to do an update. So the rest of the application, my deployment processes they obviously shouldn't be doing an update. They just run a Composer install. There's a defined state of my application. But I do want to, on a regular basis, review, what have my dependencies changed what what bugs have been fixed there, maybe they impact me. If I just don't look at this and only do it if I'm forced to, then I'm very likely to actually run into some of these bugs in my site without even noticing necessarily. So it's kind of important that you keep on top of what is changing in your dependencies and then run a composer update when you think it makes sense. Like I would just advocate for, reviewing this on a more regular basis. I think, can you give them the mic?
When you say regular basis, I mean, how regular do you mean?
I mean, that obviously depends on the project. Do that once a day, once a week, once a month, depending on kind of, how much resource do you have to spend on this? And is it like a large project? Is it a smaller project? It really depends on, there's no one size fits all answer to this.
But if you say check the dependencies once a month, that would be like a good rule of thumb, so to speak.
I would say a good rule of thumb is to do this on a daily basis.
Daily?
Yeah. Just have this kind of automated. You don't even have to do this manually, right? It's like automate this, do it as a part of your CI system. You get an email in the morning that says the following libraries have updates. Take one quick look at it, go this thing looks like a key thing of our thing. Maybe I should read up on what they changed. And otherwise, all right, I'll take a look at this again tomorrow. And then if something is actually important to you, then you update. And it's something that should become a very regular habit of what you're doing, to be aware and on top of. Because otherwise, somebody discovers this big security hole in one of your dependencies, and you update once a month. There's a whole 29 days that this is exploitable on your site, right?
Okay.
So do this as often as you possibly can without spending too many resources on it.
So we have time for one question more. Do you have it? Okay.
All right, thank
you,
very much.
Nils. Thank you so much.